Picture the solar system without Jupiter. No giant, no swirling bands of orange and white, no great red spot, no 67 moons, just an empty orbital path where the largest planet in our neighborhood should be, and beyond it, the cold outer dark. It seems like a small change. Jupiter is far away, you've never been there, you never will be, most days you don't think about it at all. It's just a bright dot in the night sky if you happen to know where to look. It doesn't affect your weather, it doesn't pull your tides, it doesn't warm your mornings or light your evenings. But remove it from the equation, and the planet you are sitting on right now almost certainly never forms the way it did. Or if it does, it doesn't stay the way it is. Or if it does, life probably never gets started. Or if it does, something ends it long before anything like you has a chance to evolve. Jupiter is not a planet that happens to exist near Earth. Jupiter is one of the primary reasons Earth exists the way it does. And understanding why requires going all the way back to the very beginning of everything you're standing on. 4.5 billion years ago, the solar system was not a collection of planets orbiting a star. It was a vast, spinning disk of gas and dust swirling around a young sun that had only recently ignited. Particles clumped together under their own weak gravity. Clumps collided and merged. Collisions built rocks. Rocks built boulders. Boulders built planetesimals, objects large enough to have meaningful gravity of their own, pulling in more material, growing larger and faster with every passing million years. It was a violent, chaotic time. Hundreds of protoplanetary bodies were jostling for position, smashing into each other, merging, fragmenting, spiraling inward, spiraling outward. The solar system looked nothing like the neat, stable arrangement of 8 planets you've seen in textbook diagrams. It looked like a demolition derby on a cosmic scale. Out of that chaos, Jupiter formed first. This matters more than almost anything else in the history of our solar system. Jupiter didn't just form, it formed fast. Within the first few million years of the solar system's existence, before Earth had even finished building itself, Jupiter had already accumulated a solid core massive enough to begin sweeping up hydrogen and helium directly from the protoplanetary disk at an extraordinary rate. It grew to 318 times the mass of Earth in what is, by geological and astronomical standards, almost no time at all. Think about what that means. While the rocky inner planets were still grinding themselves together through billions of individual collisions, Jupiter was already a colossus. It had already become the gravitational anchor of the entire outer solar system, and its influence wasn't passive. It was active, dynamic, and far-reaching in ways that would determine the fate of every single planet that came after it. Planetary scientist Kevin Walsh and his colleagues proposed what is now called the Grand Tack hypothesis. The idea is that Jupiter, early in its history, didn't stay where it formed. It migrated. It moved inward toward the Sun, carving a slow but unstoppable path through the inner solar system, sweeping debris, flinging material outward and inward, reshaping the protoplanetary disk in its gravitational wake. Then Saturn formed behind it. The gravitational resonance between these two giants, a precise mathematical relationship between their orbital periods, caused Jupiter to reverse course and migrate back outward to roughly where it sits today. This inward then outward migration, the Grand Tack, explains several puzzling features of the inner solar system that had long confused planetary scientists. It explains why Mars is so much smaller than it should be. Mars sits in a region that was severely depleted of material by Jupiter's inward passage. Without that depletion, Mars might have grown as large as Earth or even larger. It explains why the asteroid belt between Mars and Jupiter is so sparsely populated compared to what the models predict it should contain. Jupiter swept it clean, scattering objects into unstable orbits or flinging them out of the solar system entirely. And it may explain something even more profound, why Earth ended up with the precise mix of water, carbon, and nitrogen that eventually allowed life to begin. Some of Earth's water didn't form here, it was delivered. Comets and water-rich asteroids from the outer solar system, disturbed by Jupiter's migration, fell inward into the inner solar system and seeded the early Earth with the oceans you see today. Without Jupiter playing the role of gravitational slingshot, that water delivery might never have happened. Now imagine Jupiter never formed. The protoplanetary disk that built the inner planets keeps all of its material. None of it is swept away. None of it is flung outward. The asteroid belt doesn't get cleared. Mars grows large. The inner solar system remains crowded and chaotic for far longer than it actually was. Earth, if it forms at all, forms in an environment of relentless bombardment. Not the late heavy bombardment that geologists believe actually occurred, a relatively brief and intense pulse of impacts that may have paradoxically helped deliver water to early Earth, but a permanent, grinding, continuous rain of rocky and metallic debris that never fully subsides. Early Earth needed a window of relative calm, a period after the initial chaos of formation in which the oceans could stabilize, the crust could solidify, the atmosphere could settle into something breathable, and the first fragile chemistry of life could begin to find its footing. That window exists in our solar system in part because Jupiter eventually cleared the inner system's most dangerous debris and began acting as a gravitational gatekeeper for the outer solar system. Without Jupiter, that window may never open, or it may open briefly only to be slammed shut by a catastrophic impact before anything more complex than single-celled organisms has time to emerge. But the story goes even deeper than the ancient past, because Jupiter's role isn't just historical, it is ongoing, right now, tonight, as you sit wherever you are. Jupiter is acting as the solar system's most powerful gravitational shield. Its immense mass, sitting at the boundary between the inner and outer solar system, deflects and captures comets and asteroids that might otherwise be on collision courses with the inner planets. Astronomers have directly observed this in real time. In July 1994, comet Shoemaker-Levy 9, discovered by astronomer Carolyn Shoemaker, her husband Gene Shoemaker, and David Levy, broke apart under Jupiter's tidal forces and slammed into the gas giant in a series of 21 distinct impacts spread over 6 days. The individual explosions released energy equivalent to hundreds of millions of nuclear weapons each. The dark scar marks left on Jupiter's upper atmosphere were so large they were visible from Earth through amateur telescopes for weeks afterward. That comet could have hit Earth. Given the right conditions, a comet on a similar trajectory in a Jupiter-free solar system would have had no giant planet to intercept it. It would have continued inward, and a comet of that size striking Earth would have been an extinction-level event, the kind that ends evolutionary experiments, the kind that resets the biological clock. In a solar system without Jupiter, the rate of large impacts on the inner planets would be dramatically higher. Some planetary models suggest the impact rate on Earth without Jupiter could be tens to hundreds of times greater than what we actually experience. At that rate, complex life as it exists today could not have survived. Every time multicellular organisms began to gain a foothold, every time evolution took a step toward something more intricate and interconnected, a large impact would reset everything back to the simplest possible starting conditions. You are here reading this, in part because Jupiter absorbed hits that were meant for you. But here is where the story becomes genuinely strange, because Jupiter is not entirely a protector. It is also, in certain configurations, a threat. Jupiter's gravity doesn't just deflect comets outward and away from Earth. Sometimes it deflects them inward, sending them on new trajectories toward the inner solar system. The balance between these two effects, Jupiter as gravitational shield versus Jupiter as gravitational catapult, is delicate, contested, and has been studied and debated by planetary scientists for decades. Some models suggest that a slightly different Jupiter, positioned at a slightly different orbital distance, could actually increase the impact rate on Earth rather than decrease it. The solar system we have is not just lucky to have Jupiter, it is lucky to have Jupiter in precisely the orbit it occupies at precisely the mass it has. Small changes matter enormously at this scale. Astronomer John T. Horner at the University of Southern Queensland has spent years running detailed simulations of what happens to Earth under different Jupiter configurations: lighter, heavier, closer, further, absent entirely. His results suggest that the relationship between Jupiter and Earth's impact rate is deeply complicated and nonlinear. Move Jupiter slightly, and the solar system's behavior changes in ways that are difficult to predict and sometimes counterintuitive. Remove Jupiter entirely, and the inner solar system becomes a fundamentally more dangerous place on timescales relevant to the evolution of complex life. We live on a planet that was shaped by a giant we can barely see with the naked eye on a clear night. A planet so massive it contains more than twice the material of all the other planets in the solar system combined. A planet whose gravity has been silently co-authoring the story of Earth for 4.5 billion years, clearing debris, deflecting threats, delivering water, and holding the gravitational architecture of the solar system in a configuration that turned out to be unusually hospitable to life. Carl Sagan famously observed that we are made of star stuff, that the atoms in your body were forged in the cores of ancient stars that exploded long before our sun was born. But we might equally say we are made of Jupiter stuff, arranged, protected, and in some fundamental sense, delivered by the gravitational influence of a planet most people never think about, sitting in the dark hundreds of millions of miles away. When you look up at the night sky on a clear evening and find Jupiter, a steady, bright, yellowish-white point of light that doesn't twinkle the way stars do, because it is close enough and large enough to show as a disk rather than a point source, you are looking at one of the central characters in the story of your own existence. It cleared the orbital path, it took the impacts, it delivered the oceans, it scattered the material that built your body, it held the gravitational balance that gave chemistry the time it needed to discover life. You've never been to Jupiter, you never will be. It is 600 million miles away on the nearest approach and nearly 1 billion miles at its furthest. It is a place of crushing pressure, howling storms the size of continents, and radiation fields that would destroy any human-made electronics within hours. But it has been shaping your existence since long before this planet had a name, since before the oceans existed, since before the first cell divided in the first warm tide pool on the first stable shoreline of an early Earth that was still learning how to be a world. The next time you step outside on a clear night and look up, find that steady, bright point in the south. That is not just a planet. That is the reason you are standing there to look at it. And here is the thing that makes this more than an interesting fact about planetary science. It changes the way you think about life in the universe. If Earth needed Jupiter to become what it is, if the formation of a stable, water-bearing, life-supporting rocky planet requires a giant outer planet in precisely the right orbit at precisely the right mass, then the emergence of complex life anywhere in the universe becomes rarer than we might have hoped. You don't just need a star. You don't just need a planet at the right distance. You need the entire gravitational architecture of the system to be arranged in a specific way. You need a Jupiter, positioned correctly, formed at the right time, massive enough to do the job without doing too much of it. Some solar systems may have Jupiters that formed too late, leaving the inner planets to be destroyed by debris before they could stabilize. Some may have Jupiters that migrated too far inward, plowing through the habitable zone and flinging any rocky planets outward into frozen orbits. Some may have no gas giant at all, leaving their inner planets exposed to a relentless bombardment that never ends. We don't yet know how common our particular arrangement is. Astronomers studying exoplanet systems are finding Jupiter-sized planets everywhere, hot Jupiters orbiting impossibly close to their stars, gas giants in wildly eccentric orbits, systems with multiple giants that have torn each other's orbits into chaos. What we don't often find is a system that looks like ours. A single well-placed giant in a nearly circular orbit, far enough out to be a shield, close enough in to have shaped the inner planets during formation. Our solar system may be unusual, and if it is unusual, then so is Earth. And if Earth is unusual, then so are you. Every breath you take, every thought you have, every moment of your existence is downstream of a cascade of events that began 4.5 billion years ago when a cloud of gas and dust collapsed into a disk. And out of that disk, a giant formed first, fast, and in exactly the right place. Jupiter didn't mean to protect you. It has no awareness, no intention, no concern for the pale blue dot that formed in its gravitational shadow. It is just mass, just gravity, just the blind physics of a universe that occasionally arranges itself into configurations that allow something like you to exist. But it protected you anyway. And it is still out there tonight, sweeping the outer solar system, deflecting threats you will never know about, maintaining the gravitational order that keeps your world intact. You've spent your whole life on a planet that needed a giant to survive. Now you know its name.